Yes, dear students, here the topic here relation between electric field and potential difference. Today topic is relation between electric field and potential difference. In figure here, we are representing uniform electric field with parallel lines and equidistant. There are 2 points B and A at distance delta x. If we have a charge Q0 at point B, then this action force F equal to Q0 into E. Q0 is a very small charge so that it does not affect the uniform field. I have told you tending to 0 means small, so small that its field is not significant here, but it actions force Q0 into E. Now if we move this charge 0 from B to A, work has to be done. तो मैं लिखूंगा कि let in figure there are 2 points A and B in uniform electric field. Electric field E. If a test charge Q0 tending to 0 is carried from B to A, then work will be done by against force Q0E. To do this work against this force, we need to apply a force equal and opposite to Q0E. Equal and opposite. If external force applied is more than this Q0E, then particle may have acceleration, and due to acceleration velocity will increase, and that increase will increase the kinetic energy, which we are not considering. So Q0E. So work done in carrying charge Q0 from B to A. D delta W, I will write delta W. Q0E dot delta X. Here Q0 is the force applied by electric field. And in carrying that electric field, so in fact will carry it away from along the field. But we are bringing it, so we have to apply equal and opposite force. Now dot product or minus Q0E delta X, where delta X is the distance between points A and B. Minus sign here because negative sign. You can write here Q0E delta X cos 180. Why force symmetry? Because force this way and displacement this way. So minus this. So there is no need to write here. Or delta W upon Q0 is equal to minus E delta X. But by definition of potential difference, delta W upon delta X, delta W upon delta X क्या होगा? Potential difference between points B and A. But here delta W upon delta X is equal to VB minus VA, which we write as delta V, and hence delta V is equal to minus E delta X, or we can write here it as E is equal to minus delta V upon delta X. If delta X tends to 0, it is whole, then this equation can be written as E is equal to minus dV over dx. So a uniform electric field is equal to negative of potential gradient. Here dV over dx. Here dV over dx represents change in potential per unit distance. The change in potential, per unit length या per unit distance कह लीजिए, distance is called potential gradient. Potential gradient. What is potential gradient? Change in potential per unit length. In books it is written change of potential, rate of change of potential distance. That becomes a you see, confusing language. Change in potential per unit distance is called potential gradient, and hence uniform electric field is equal to negative of potential gradient. Potential gradient. From here, unit of electric field may be used as volt per meter. Unit of electric field may be treated as volt per meter. Till now we were using unit of electric field or electric intensity as क्या भाई Newton per coulomb, तो volt per meter. And you may be asked to write the dimensional formula for electric field. Basically, I think I have told you. I told that basically E is equal to F by Q0. So Q has dimension 80 or force MLT minus 2, MLT minus 2 upon 80, अब तो डायमेंशन फॉर्म क्या बनेगा, M L T सॉरी माइनस 4 T minus 3 A minus 1. We will ask like that. Now negative sign indicates here. Listen children, this is very important here. Minus sign indicate in equation E equal to minus dV over dx. Negative sign here. Negative sign indicates that electric potential decreases with distance in the direction of field. Of electric field. Why? Actually, delta V means है VB minus VR, VA, और यहाँ माइनस है. This left hand side positive, तो VB smaller than V होगा तो this value become negative और negative become positive. So negative sign here indicates that potential decreases. Field is uniform. Field हमारा uniform है, but potential will decrease because potential का amount of work done. Now here we can consider one more point here, which is very important for you to learn. Because in different exam, questions are asked on that particular topic. What is that? Potential electric potential, I should say. Electric potential due to charge conducting cell. Very important to learn and important to understand. Suppose here it is a charge cell whose radius capital R, center O, and here is a point P outside at distance R, and this cell has total charge Q. This charge capital Q. In this figure, it is conducting cell of radius R having charge Q distributed uniformly over the whole space. From Gauss theorem, electric field at P is given by E equal to 1 upon 4 pi epsilon 0 Q by R square. distance from here, but charge distributed here. So whole charge appear distributed, concentrated at center. So आ जाता Z पाथ. चुप करना. हाँ भाई. तो from this formula it appears that whole charge is center. And if this charge is at center, then potential due to point charge Q. This equation shows that a 1 minute, and at surface E equal to 1 upon 4 pi epsilon 0 Q by R square. And therefore, for a point outside cell, for a point outside the cell or on the surface of cell, whole charge appears to be concentrated at center. Please try to understand what I say. This charge spread here on the surface, but for this point over here, the field are given by this and this. This is the electric due to point charge where distance r, and the same thing. So this for this surface also, this charge not appear, it appears this. And we know electric potential due to point charge q at distance r. क्या होता है भाई? Electric potential, and we know electric potential due to point charge q at distance r is V equal to 1 upon 4 pi epsilon 0 q by r. I think it should be very clear. And therefore electric potential at any point outside cell at distance r, and potential at any point outside cell V equal to 1 upon 4 pi epsilon 0 q by r, and on surface V equal to 1 upon 4 pi epsilon 0 q upon capital R. Now what if point is inside here? What is potential inside? This is important to understand here. Potential is the amount of burden against the electric field when we are carrying it. Here is the electric field due to here, everywhere, electric field, but decreasing with distance. But when we come to this point, this is the maximum. Inside E is equal to 0. So no more work will be done in carrying the charge from outside to any point inside. So हम यहाँ क्या लिखते हैं? Since inside the charge cell, since inside the charge cell equal to 0. So, no more work is done in moving test या charge from surface to any point inside the cell. So potential at every point inside every point so little हो गया मामला every point inside the cell inside the charge cell is equal to potential at its surface, that is V equal to 1/4 pi epsilon 0 Q by R. Whether point is here or at center, because electric field inside the charge cell 0, and if we come inside imaginary and take the charge towards center, then no more work is done. Only work is done in carrying charge to surface, because field is only outside. So this is very important. I will give you question based on this, and you have to learn it for different exams. Thank you.